So here is part 2. And I'm on number 17, it says find the length of the midsegment. So it tells me it's a midsegment, but it really didn't have to tell me because this intersects at the midpoints of these two sides of a triangle, which means this is the midsegment, which means it's parallel to the third side and half its length. So when you know that, you know exactly how to set up your little equation. The midsegment, which is 4n plus 5, is equal to half the third side, which is 74. Okay, so midsegment is half the third side, so that means that gives me 4n plus 5 equals half of 74, which is 37. So I subtract 5, and I get 4n equals 32, so n equals 8. But it didn't ask me for n, it asked me for the midsegment. I need that, but then I got to plug it back in right here. So 4 times 8 plus 5. So that's 32 plus 5, which is 37. Where else did we just see that number? Right here, right? Since it didn't ask me for n and it just asked me for the midsegment, I really didn't have to solve for n. Read the question. Just saying. Get the same answer though, but you didn't really need it. All right, so then number 18 says, and y'all can stop me if you have a question. Write the angles of triangle RST in order from largest to smallest. So it gives me the side lengths, but I want the angles, and I'm writing them from largest to smallest, which means I'm looking for the biggest side length. That would be this one. So the angle across from it's the biggest angle, so I start with angle T. Then the next longest side is this one, and across from that is R. And then angle S. Okay. 19 asks me to write the sides in order from shortest to longest, so I just had to write the angles. This time I am writing the sides, and it is from shortest to longest. If I don't have all 3 angles, then I need all 3 angles. I need to find them, but I do have all of them. So the shortest sides across from the smallest angles, so across from 43 is line segment BC. Then the next one is across from 46, which is line segment AC. And then, what do I have? BC, AC, and then that leaves me AB. And these are, notice these are named as line segments, these are named as angles, there's no little measure here, and this doesn't have the top missing. Okay. All right, next one. So tell if the measures can be side lengths of a triangle, because remember, if just because you have 3 sides doesn't mean it necessarily fits to make a triangle. The theorem actually says that you are supposed to try all 3 sets, but truly if you just take the smallest 2 and add them together, so 9 plus 17, and I want to know how that relates to 26. Well, 9 plus 17 is 26. That equals 26. So that means that this is not going to make a triangle because the 2 smallest sides have to add up to be bigger than the third side, not equal to. So here I take the 2 smallest sides and I get 2 plus 3.7 and put a little question mark there, 4.1. So this is going to give me 5.7 is greater than 4.1. So that works. So the answer is yes. And your work is your support of your answer. Everybody good? All right. Extend this a little bit. Come on. My board is tired. There we go. Oh, goodness. Okay. So here we're going to write the equation of the line that is the perpendicular bisector of the line segment with these endpoints. So you don't have to draw a little picture, but I think sometimes it's good to get your mind wrapped around it. At negative 7, 7, and 3, negative 7. Somewhere right about there. So this is my line segment. That is not the equation that I'm trying to write. I'm trying to write the equation of the perpendicular bisector, which would be somewhere over here, but all that's ballpark, so I wouldn't even be willing to guess on quadrants or anything, but it does give me an idea of what's happening here. In order to write this equation, it doesn't say what form I have to write it in, but by far the easiest here would be y minus y1 equals m times x minus x1. So in order to write that, I need slope, and I need a point. So a point on the green line is the midpoint of the line segment. So I need to do the slope and the midpoint. So I can find slope. Slope is delta y over delta x. That's going to be negative 7 minus 7 over 3 minus a negative 7. That's negative 14 over 10, which is negative 7 over 5. But that's not the slope I want. That's just the slope of the segment. I need the perpendicular slope, which is a positive 5 over 7. So that's the slope I'm going to use in my equation. The midpoint formula is easy. x1 plus x2 over 2, y1 plus y2 over 2. And I'm using the endpoints of the segment, so this gives me negative 7 plus 3 over 2, and 7 plus a negative 7 over 2. So negative 7 plus 3 is a negative 2. I'm sorry, no, is a negative 4. Divided by 2 is a negative 2. And then 7 plus 7 is 0. Over 2 is 0. There is the point that I use. There is my slope. I'm putting it in point slope form, and I'm going to stop so I don't have to do anything else. So I'm going to do y minus y1, which is 0, equals the slope, which is 5/7, times x minus a negative 2, which makes it x plus 2. And then I am done. This could just be y equals 0, or just y here, not y minus 0, but I already wrote it, and it's okay like that, so I'm not even going to bother rewrite it, and that's fine. Okay, we all good with that? Any questions? Okay. Next, if you do have questions, you can always go back and rewatch this. Or, just stare at it. There you go. So I need to name the side that is included. Some of us are having a big problem with this whole included. So here's angle G, and here's angle O. The side that is included in those two angles is the side that touches both of them. So it is line segment GO. The angle included by GO and EO is this angle right here, which is angle O. Okay? The whole included, not included thing is very, very important. All right, so number 25. If triangle TOM is congruent to triangle MEG, then angle O is congruent to angle E, angle T is congruent to angle M, and line segment TM is congruent to MG. And I just realized that I just did these two questions, I'm pretty sure. I'm sure I did those last period, which tells me they're on a different part of the review. Let me go back and double check myself here. I'm not going to do them again. Yeah. Okay, so this right here, 5 and 6, is the same as 26. So you can see number 5 and 6. Not that they're hard, it's just still not going to do them again. Oh, and this one too comes right after it. If that wasn't 5 and 6, I don't know what that one was. But I did that one too. Probably could have just redone them by the time that was 7. By the time I figured out which ones they were, I could have just done them again, and then this one is just number 7. That is me probably cutting and pasting and trying to make things fit better, and then I forgot to go back and delete something off, and then it still didn't fit, I'm guessing. All right, so this says, tell if these triangles are congruent, and really there should be like way more to that. I didn't go back and fix that either. If you are going to label something, okay, so this is important, because I've been taking up this homework all day. Right, that y'all were supposed to do. The directions are clear on the homework. I said it in the notes every day. Every example that I did it every single time. And then a lot of you didn't do it at all. On this one, before I do anything, there's something else that I know. So I have to label it. This is labeling it. Bam. Then I have to state it. I have to say that line segment DB is congruent to line segment DB. Like I have to literally write that down. They are line segments with the little segments above them and everything. And it is by the reflexive property of congruence. Not a single time did I ever write just reflexive property or just reflexive or anything. I mean, we are abbreviating, but you have, all of that is necessary here. Okay, so now what I have, I've got these two triangles, right? So I have two sets of sides and this set of angles, which is a right angle. So the right angle is going to take me one of two directions. Either I want those angles to be congruent, or I want those angles to tell me that I have right triangles. If I'm going to try and use HL here, then I need it to tell me I have right triangles. But this is two sides in the included angle, which means what I really want are for these angles to be congruent. So I need to state that, because what they gave me is not that it is congruent. So I need to say that angle ADB is congruent to angle CDB. And the reason is all right angles are congruent. If you try and tell me all right triangles are congruent, you are wrong. Okay? If you tell me because they're right angles, that doesn't make any sense either. Okay? So I have these two things here that I have now said. So then I can say that these two triangles are congruent by the side angle side congruence postulate. And I know it doesn't say this either, and it didn't say it on your homework, and you didn't have to do it on the homework you just gave me. But if it says to also write a congruence statement, okay, so yes, these are congruent statements right here, but they're congruent statements about pieces. I need the triangle congruent statement. So triangle ADB, or ABD is what I wrote. I didn't say that, but whatever. I'm not going to rewrite that. ABD is congruent to triangle CBD. And you got to make sure that your order is right. All right? All that stuff there is important. So then I look at this one. On this one, they're not even numbered. There's nothing extra that I can label. There is. I can't say that there's nothing. There is. I could label that angle J is congruent to angle M. And I can say that that is true by the third angle theorem. And that's fine. There's nothing wrong with that. I just don't need to, because I have enough to say that they're congruent. I have two angles on the non-included side, so at this point I can say they're congruent by the angle side congruence theorem. If you go on to say that angle J is congruent to angle M, and it's by the third angle theorem, and you do all that correctly, and then you tell me it's by angle side angle, that's okay, but you would have to have that to back it up. And on the homework, on the instructions that one was due today, I said there are different ways to do some of these. So if you had done angle side angle and it counted it wrong, as long as you can argue with, argue your case and say, hey, look, I did this, so that should make it angle side angle, I'd be fine with it. I want you to be able to try and justify why you're right, even though you were counted wrong or something like that. That's important. That means you understand it. But I would just go with this, so I wouldn't have to do anything else. And I can say that triangle JHK is congruent to triangle MLP. And then I think I can get these next two done. Here, these angles are congruent. I know that because they're vertical angles. So I can't just say vertical angles are congruent. I have to say that angle JLK is congruent to angle PLM. And the reason for that is if they are vertical angles, not if they are vertical. If they are vertical angles, then they are congruent. Then by that, I have enough to say that these two triangles are congruent by angle side angle. So I can say triangle MPL is congruent to triangle KJL. Like that. Here, this is congruent by the reflexive property. So I have to say that. AD is congruent to line segment AD by the reflexive property of congruence. Here I have right angles again. This time I don't want them to be congruent, because if they're congruent, well, they are, I mean, I can't help that, but they're congruent, that would be side-side angle or angle side-side. That doesn't work. Okay, I need them to be right triangles. So here I can say triangle ADB and triangle DAC are right triangles, Okay, and they are right triangles because they have a right angle, so this is by the definition of right triangles. So I've got these two things said. That means that these two triangles are congruent by HL. So this is HL congruence. My triangle congruence statement would be triangle ADB is congruent to triangle, let's see, ADB would be DAC. Okay. So I'm gonna stop there for part 2, which means I'll do the rest on part 3. So there'll be 3 parts to this review.